In this video, I want to introduce rational expressions. These are ratios of polynomials. All right, so for example, 3x minus 1 over 4x, x over x plus 1, and 1 over x. Okay? Now, one thing that is special about rational expressions is that they have limited domains. The domain is the set of allowed values for x. So whereas with polynomials, you can plug in any number, any value you want for the variable, that's not the case with rational expressions, okay? The reason that that's not the case is because you cannot ever divide by 0, all right? So what that means is there's certain values that are not allowed, all right? For example, the first rational expression, you can't have x equal to 0, okay? X can't be 0 because if it did, you'd be dividing by 0. Also, on the 1 over x, the last expression for that one, you can have everything but 0, okay? Now, let's do the middle term. For the middle term, we still want to avoid a 0 denominator, but in order to avoid a 0 denominator for that one, can you see that we actually have to avoid minus 1? Because if we plug in minus 1 for x, that's what's going to give us a denominator of 0. Okay, so keep that in mind. That's an important point to this introduction to rational expressions. Okay? And another point I want to make in this introduction is that rational expressions can be simplified. You can reduce rational expressions similarly to how you reduced fractions in the past. In order to do that, however, you need to factor the top and bottom. For example, suppose I factored the polynomials at the top and bottom of a rational expression, and I got x plus 1 times x plus 2 divided by x plus 1 times x plus 3. Okay? That rational expression is equal to the rational expression I get by canceling out the x plus 1s. Okay? This is reducing this rational expression. All right? So keep that in mind. Okay? And then another point I want to make in this introduction is sometimes when you're trying to reduce rational expressions, sometimes you will have this situation. Suppose on top you had something like a minus b times c plus d, and on bottom you had b minus a times, x plus 1. Okay? Or let's just go ahead and do c plus d. Let's see what happens there. Okay? All right. So in this situation, okay, there's no problem canceling the c plus d's. Okay? They are the same on top and bottom. We factor the top and bottom, so we can go ahead and factor those. Now, what about the remaining binomials? Okay? They look similar, but they aren't exactly similar, right? Okay? In order to explain how to handle that situation, let me bring something to your attention. Look at what happens if I swap the order in a difference. Okay, let's focus on numbers in the upper right for a minute. What's 5 minus 4? That's 1. What about 4 minus 5? Well, that's minus 1, right? 10 minus 2 is 8. What's 2 minus 10? That's minus 8. So can you see that swapping the order multiplies the answer by minus 1? So what that means, there's a couple ways to look at this. You could go ahead and cancel these, and you have to add a minus 1 to compensate. Or in your mind, you could think of it as a minus b over b minus a is the same as a minus b over minus 1 times minus 1 times a minus b. Okay? Okay, so when you swap the order, you have to introduce a minus 1. Now you can go ahead and cancel, and you see you have a minus 1 left over. All right? So to reiterate, rational expressions are ratios of polynomials. They have limited domains. Those are the set of allowed values. and you can reduce rational expressions by factoring. All right, and remember, you cannot divide by 0. That has to do with the limited domains. And then also remember this idea for differences when the terms are inverted.